everyone, welcome back to Chem Corner. Today we are diving into the last part of AP FRQ 2025, question number 7. Let's get started. Let's do this question. Answer the following question about the glycolate ion C2H3O3 minus which act as a base in aqueous solution. A Lewis diagram of the ion is provided. And first question, on the Lewis diagram in part A, circle the atom that accept of the proton when glycolate ion react with the water. Since it is a base, definitely they will accept H plus. So which atom is going to accept this H plus? That's the thing. So definitely which one? Hydrogen will not accept again a hydrogen. Oxygen atom is more preferred, right? Carbon is already, see the Lewis diagram, carbon, this oxygen is already, the valency is satisfied like 2, oxygen is divalent, right? So 2 bond is always preferred surrounding with oxygen. And carbon, it's a tetravalent. So 4 bond have to surround with a carbon. So see, here carbon is also satisfied. This carbon is also satisfied. This oxygen is also satisfied. So the only oxygen which is not satisfied is this oxygen. So you can draw or you can circle this oxygen. Okay, the oxygen with a 3 lone pair of electron that will going to accept H plus. Okay. Then the next part, when the glycolate ion react with the water, it forms glycolic acid, and they were given the reaction and the Kb value also. Okay. Then what you want to do? The B part, at 25 question, a 2.5 molar solution glycolate is found to have OH minus this one. Okay, calculate the Kb. So in this question, actually you don't want to need the ice table, right? Because the OH minus concentration is given, but anyway, we can just clear the idea. So what about ice table? Like Kb, always we are doing with the ice table. Equilibrium concentration we need, right? Okay, they were started with a 2.5 molar solution and this one is 0, this one is 0, H2O I don't want to consider it is liquid, and change it's minus X and C 1:1 ratio, so X and the equilibrium is 2.5 minus X and this one is X and this one is X because initial zeros are 0. Okay, then what is this X? They were already told OH minus concentration at equilibrium is 1.3. So this X is nothing but 1.3 times 10 to the power of negative 5. Then see, this is also X. So this is also the same value, 1.3 times 10 to the power of minus 5. Okay, and if X is given, so it's better to apply that X. 2.5 minus 1.3, usually we will skip this X, correct? We do not want to write the X, we are just assuming 2.5 minus X is 2.5 again. But in this case, since we have the X, you do not want to remove that one, you can apply that one. Okay, 2.5 minus 1.3 times 10 to the power of minus 5. Then you can substitute in the question. So while you substituting 1.3 times 10 to the power of minus 5 and again the same value, so square divided by this thing 2.5 minus this 1.3 times 10 to the power of minus 5. So what we got is 6.8, because 2 significant figure only we need, 6.8 times 10 to the power of minus 11. Okay, so that will be the Kb value. Then the second part, using your answer to question to part B, calculate the value of Ka of glycolic acid. So Kb we already found. Then what is Ka? Kw is equal to Ka times Kb, like that equation is there, right? So you can calculate Ka by direct application of that equation. Ka is equal to Kw over Kb. Kw value we know that 1 times 10 to the power of negative 14, and now we know the Kb value which is 6.8 times 10 to the power of minus 11. We just found this value from here. Okay, so the same value. Then what we got as Ka 1.5 times 10 to the power of minus 4. Okay. Then the third part, glycolic acid can be produced from the hydrolysis of methyl glycolate and the mechanism is given. Okay. A student claimed that H3O plus is a catalyst for the reaction. Do you agree or disagree? Justify your answer based on the mechanism given. Okay. If it be a catalyst, what is the thing? How do you know it's a catalyst or not? catalysts are consumed in one step and regenerate in another step, isn't it? That's we studied about catalyst. If it is a catalyst, it have to be used in one step and it can be regenerate. It will be again produced. Okay, that is the catalyst. So let's see. Step 1, see step 1 H2, it consumes H3O plus. Okay, yeah, see the step 2, H3O is regenerated. H3O plus is regenerated. So definitely H3O plus is a catalyst. So we can agree to that statement. Why? Because of this thing. Okay, catalyst consumed in one step and regenerated in another step. Okay, that's all. That's all. If you enjoyed this video, don't forget to like, share, subscribe for more videos. See you in another video. Until then, keep learning and stay curious. Bye.